Hi, I'm Bob Leake. I'm one of the developers of the Variable Speed Zebra, and I wanted to introduce you to one of our new adapters. It's for the X-13 motors that are just starting to be shipped, and I'd like to give you a little bit of a heads up on how to install them and how they work. I want to thank you for purchasing the X-13 adapter, but I wanted to remind you of two things that you need to know now before you go any farther. You need to have a Variable Speed Zebra to hook up the adapters to, and the Variable Speed Zebra needs to have a serial number that's at least 30,000 or greater. If it isn't that high, if you've got a 20,000 series, give us a call at 512-869-7000. Ask for tech support. We will do a no-charge software upgrade to your Variable Speed Zebra. All you have to do is pay for the freight to get it here and back. The X-13 adapters for the Variable Speed Zebra consists of two different pieces. One of them with a fuse holder that connects to the wires coming from the furnace or air handler board, and one that has no fuse holder that connects directly to the motor. To make connections to the motor, remember, one, to shut off your power first. The wires that are closest to the shaft have either 120 or 240 volts. Can you see that well? Okay. The first wire that you disconnect is the C or common wire, and you hook up, there's a legend on the motor harness. You see where it says C, that's the blue wire. You hook that up to the same terminal that the C wire, common wire, came off from. The other wires, from 1 through 5, this particular furnace model only has 2 wires, 1 and 4. So we're going to disconnect them, remembering which one they came from. The green wire went to the number 1 terminal. The number 1 terminal on this harness is white. So we're going to hook that up to the number 1 terminal on the motor. The number 4 terminal was blue. We're going to hook that up to the number 4 terminal here, which is green. The second adapter, the one with the fuse holder on it, is the one that connects to this board. Remembering the wires that we disconnected from the motor, the one that was going to the common terminal or C terminal on the motor, C here says blue, so we need to hook that up to the blue. There is really no standardization of wires, so you're going to have a little bit of confusion. You never are going to hook color to color unless it's just serendipity. The second wire, this went to the number 1 terminal on the motor. Number 1 here shows white. See these little terminals that are on here? I like to leave a terminal on each of these wires unless you're actually using it. You won't always have 5 wires. This case there only uses 2. This keeps these terminals from accidentally hitting anything live. They're just raw shielded terminals, so if you ever lose them you can buy them at any distribution center. The last wire that went to this unit went to the number 4 terminal, and number 4 here says green. We'll take off this protective terminal and hook this wire up to the green one. The last thing that you do is carefully hook up the red alligator clip that's fused through the fuse holder. By the way, this is a 1 amp fuse. Never put anything greater than a 1 amp fuse in here, or you risk damaging your Variable Speed Zebra. Always remember to only hook it up to 24 volts. If you ever hit a 240 or 120 terminal, you're probably going to blow the electronics on your Variable Speed Zebra, and it won't be warranted. So be careful at this point. I'm going to turn the power back on. By the way, one of the tools that we're going to use to demonstrate the features of this adapter is our ZebraStat. It's a great companion product when you're doing diagnostics and troubleshooting, and instead of using a thermostat to control this unit, we're going to use our ZebraStat like we were in a furnace closet. The last steps are to hook up your Variable Speed Zebra's gold harness to the harness of the adapter that goes to the board. Be really careful when you push these connectors together. The terminals can be easily damaged. And you'd hook up the blue, the motor harness, to your X-13 adapter's motor harness. At this point, you'll see the typical red and green flashing mode light reminding you to select a mode for the variable speed zebra to operate in. To put your variable speed zebra into X-13 mode, which you have to do for X-13 motor testing, the setting step switch is pressed and held in the down position for at least 8 seconds. When you do this, after 8 seconds, a 13 will come up on your master display. That tells you you're in X-13 mode. If that 13 doesn't come up and your variable speed zebra is powered up, double check your serial number to make sure that it does start with a 3 or greater. You may need to upgrade the software. As we mentioned earlier, it's a no-charge upgrade. All you have to do is pay the shipping to the factory and back. Limitations of X-13 motors include 3 things that the normal variable speed motors have. First, there is not going to be any CFM or RPM display while these motors are running. They don't feed back that information. It's a less expensive motor for the manufacturers to put in their furnaces and air handlers, and that's one of the things they gave up when they made that choice. Number 2, there are no taps available to make fine-tuning adjustments, so these tap lights will never be lit up. And number 3, the option step switch on your variable speed zebra does not do anything. The voltage switch, this particular transformer up there, is putting out 29 volts, a bit high but still serviceable, and the winding test sequences, which we'll go through how to do that later, still work the same, as well as the observe and control modes. They work exactly the same as your variable speed zebra has always worked, except the lights from here, because the X-13 motors do not use the conventional calls for heat 1, second stage heat, or lower high cool, or they don't have inputs for the reversing valve or the humidistat. The lights that are on the top on this section of the board are just simply numbered 1, 2, 3, 4, 5. So if you'll think of them as numbers instead of what this legend says on the variable speed zebra, then you'll truly understand the way the signals are working. If this light is lit up right here, you're getting a signal coming from your furnace board on line number 1. And if it's lit over here, if this LED is lit, then it's sending a signal down line number 1 to the motor. Let's go ahead and get into that mode. We're going to look at observe mode, so our LED is green, and we're going to use the zebra stat to turn on heat 1. As you can see right now, as soon as we did that, the motor was powered with a signal on line number 4. Remember, on this motor there's only 2 signal lines actually being used. It's number 1 and number 4, so we hooked them up over there. They didn't take advantage of all the different options that were available. Here's something I'd like to point out to you. You see the number 1 line LED is glowing just a little bit red. That's called feedback, and it's coming from your motor, and it's something that since it's not full brightness, you can pretty much ignore it. It's just a little bit of feedback generated by that motor, and it's coming in on the signal line. These motors do have a delay built into them, as well as the furnace boards. As you're noticing right now, even though we cut off our call for heat, and pay no attention to the fact that that says cool 2, the heat call sent its signal out on line 4. So remember, this is line 4, not cool 2. So try not to get those confused. The light for position 6 and 7 are not used in this implementation of the X-13s. They're reserved for future use. If you're trying to diagnose a system that doesn't seem to be operating properly, one of the things, just like you do on a normal variable speed motor test, is observe the signals coming in from the control board on the furnace on your left-hand side. And then if you're in observe mode, those signals are passed straight along to the right-hand side, to the motor, and you watch how the motor responds. When you want to control how those signals are passed and break the system in half, and you want to control the motor directly, you're going to use this setting step switch to select either 1, 2, 3, 4, or 5. You can actually go up to 6 or 7 on this, but they aren't implemented yet. But say we're going to send a signal out on line 4. A few seconds later, your motor starts up. When you're using control mode and you've sent a signal and you shut the signal off so it's no longer going to the blower, sometimes that blower will keep going for up to 90 seconds. That's part of the delay that's built into that motor. If you've sent signals out to the motor and the motor doesn't operate in any mode, then it's safe to assume that one of two things is happening. Either you're not getting power to the motor on your line voltage, or the motor or the control module of the motor is defective. The first thing that you want to eliminate as a possibility is that the motor's not getting line voltage, and you can carefully stick voltmeter probes on those terminals L and N to make sure that line voltage is present. Some manufacturers use a choke, which looks very close to what a transformer looks like. Sometimes those chokes could have a problem. So you may want to make sure that your voltage is being passed through all the way to the motor, not just at the terminals on the control board somewhere. To accomplish the winding test to determine if the problem's in the motor module or the windings themselves, first thing you do is remove power to the unit. Disconnect the wiring to the motor, wait 5 minutes. If you do not do this, you may not be able to watch the rest of this DVD. The motor capacitors retain voltage for 3 or 4 minutes. If you don't give a full 5 minutes, you may get a really nasty shock. Next, remove the 2 1/4-inch bolts that hold the motor module onto the motor. Carefully pull the module straight off, rotate it around so that you can see the connector plug. This connector plug has a keeper on it. Would you zoom in on that, please? You see it good? Mm-hmm. Squeeze the keeper and disconnect the module. Some motors, this module is replaceable without buying the whole motor. It's substantially less expensive than the whole motor. We can't test the module directly, so we're going to test the windings, and if the windings are good and the motor is bad, that tells you it has to be the control module. If the windings have a defect, it's imperative that you replace both pieces of the motor, not just the windings, because the windings, if they have a defect, could damage the control module. You'll take the white connector from the VZ7 and plug it in. It'll only plug in one way into the windings module, and you will take the alligator clip on that harness and connect it to a bare metal point on the motor or something going to the motor electrically. Next, you turn the power back on. You don't have to be in X-13 mode to execute the winding test. Since you've turned your power off, you don't have to go back into that mode. Just simply press the winding test. You'll notice the display goes around in a little circle like Pac-Man. That's telling you to spin the shaft of the motor, whether it's connected to the fan or not, 1 or 2 revolutions. Once you do that, it does a number of diagnostic tests and gives you a report. Let's do that one more time. This particular digital report is 77, oops, disconnected the ground sensor, which on the inside lid of the variable speed zebra tells you that all tests are okay. So if you had determined that power was going to the motor, line voltage, the signals were going into the motor to tell the motor which speed to operate at, and this winding test gave you a 7.7, that tells you that the problem must therefore be in the electronics module. If you look at this module and you notice that this surge protector is all black and blown, but you already know the problem, It could be that a surge or high voltage or electricity came in on the line and blew that. These things usually cost less than $100 to replace. One final comment: when you use this system, and if you ever blow that 1 amp fuse for any reason, don't waste your $200 that you spent for your variable speed Zebra. Replace it with a 1 amp fast blow fuse. You put a lot of money out for that tool. Make sure that you get your money's worth out of it. It's there to protect it in case something accidentally is shorted somewhere. Thanks for using our products, and I hope that we've cleared up any confusion that you might have had about how variable speed motors are signaled and how they operate and how to diagnose when you have problems with them. Bye-bye.